Welcome back to this class. I hope you are all studying well for the exam. So exam எப்போ வரும் அப்படின்ற ஒரு டவுட் எல்லாருக்குமே இருந்துகிட்ருக்கு. ஸோ நிறைய குழப்பங்கள் போயிட்டுருக்கு. ஸோ 59 வயசு வரைக்கும் கவர்மெண்ட் எம்ப்ளாயீஸ்க்கு ஏஜ் இன்க்ரீஸ் பண்ணுறதை வச்சு நிறைய குழப்பங்கள் இருக்குது. பட் இதுக்கும் அதுக்கும் எந்த சம்மந்தமும் கிடையாது. ஸோ இந்த வேக்கன்சி ஆல்ரெடி கிரியேட்டட் ஒன். ஸோ அதனால் இந்த எக்ஸாம்ஸ் மேக்ஸிமம் கண்டக்ட் பண்ணிவிடுவாங்க. பட் இட் வில் டேக் another 2 months. அண்ட் ஒன் மோர் திங், நம்ம சேனலில் டெஸ்ட் சீரீஸ் அண்ட் மாக் டெஸ்ட் ஸோ அதை கண்டக்ட் பண்ணிகிட்ருக்கோம். ஸோ அது மட்டும் இல்லாமல் வாட்ஸ்அப் குரூப்பில் டிஸ்கஷன்ஸ் போயிட்டுருக்கு. ஸோ தோஸ் ஹூ ஆர் இன்ட்ரெஸ்டட் கேன் ஜாயின் த கிளாஸ். ஸோ இன்ட்ரெஸ்ட் இருக்கவங்க ஸோ வாட்ஸ்அப் நம்பரை காண்டாக்ட் பண்ணலாம். நவ் இன் திஸ் செஷன் வில் கோயிங் டு சி யூனிட் நம்பர் 9. This unit is very big one, so we have separated into 2 parts. In the first part la some important questions, so a direct questions sila lower order questions I have selected for solving. The next part I will discuss with the higher order questions. So in the first part we'll see the first question. The Hermitian conjugate of the minus d by dx will be. So this is the operator minus d by dx. Hermitian conjugate of this operator is minus d by dx dagger. We have seen that already. For d by dx it will be minus d by dx will be the Hermitian conjugate. So minus into minus plus will get. For Hermitian conjugate of minus d by dx will be plus d by dx will be the Hermitian conjugate of this operator. And at the same time the operator is minus d by dx and the Hermitian conjugate we have got is d by dx. So they are in the opposite, same but opposite. So they are the anti-Hermitian properties. Now the next question, eigenvalues of Hermitian operators are dash and eigenfunctions of Hermitian operator is. Eigenvalues of the Hermitian, these are the properties of the Hermitian operators. Eigenvalues of the Hermitian operators are real and the eigenfunctions of the Hermitian operators are orthogonals. So that is A is equal to A star, they are real. If it is orthogonal, psi n, integral of psi n and psi n star dt will become 0. Then it is called a orthogonal operators. The next question is, in the Hermitian conjugate of the operator is equal and negative, then the operator is called. When you take an Hermitian operators, its value is equal and it is in the negative sign, then it is called an anti-Hermitian operators. If a Hermitian operator same and positive sign, they are called the Hermitian operators. Now the next one, find the eigen operators and the eigen values of the functions sin x. This kind of questions have been asked in the previous competitive exams, so I have given here. So here the sin x is the wave function. The operators, they have asked about the operators and the eigenfunction, eigenvalue. So this is sin x. For the sin x, when you do d by dx of sin x will become cos x, and the differentiation of sin x will get the cos x. Again we are differentiating with one more time, d square by dx square of the sin x will become d by dx of sin x will become cos x. Again we are differentiating, we will get minus sin x. So on differentiating with the 2 times of the sin x will get minus sin x but in the opposite sign. So d square by dx square will be the eigen functions of the sin x, eigen operator for the function sin x, and the minus 1 will be the eigen values. So d square by dx square is the eigen operator and minus 1 is the eigen value. Next, hence the eigen operator is d square by dx square and eigenvalue is minus 1. The next one is the eigenvalues of an anti-Hermitian operators. This as I have told already, the eigenvalues of an anti-Hermitian operators, eigenvalues for the Hermitian operators are real and different eigenvectors are orthogonal. Different eigenvectors are orthogonals. If it is anti-Hermitian, the operators are purely imaginary. These are the properties of the Hermitian operators. These things can be asked directly in the examinations. If they want to ask the direct questions, they can ask this kind of questions. For an anti-Hermitian operators are purely imaginary. The values of purely imaginary are is equal to 0. And the next question. For a particle in a one-dimensional box with a potential of V0 inside the box and infinite outside the box. That is, potential inside the box is V0. If it is outside the box, it is infinitive. An energy state corresponding to n is equal to 0. This is n is equal to 0. N is a quantum number. Is not allowed. Normally we will treat the ground state energy level with n is equal to 1. That's the ground state energy for a particle in any dimensional box, whether it may be a one-dimensional box or two-dimensional or three-dimensional. So n is equal to 1 we will take, but n is equal to 0 is not an allowed one. Why? Because the total energy will become 0. So if the energy becomes 0, this is okay. The average momentum becomes 0. The average momentum is also okay. The wave function becomes 0. So this is not the one which is not allowed. The wave function should be an allowed one. It should not be 0 at anywhere. So everywhere the wave function should be 0. So it is not the it is the wrong one for this. This is not the allowed one for this question. So the wave function should become 0 everywhere. So because of this, n is equal to not 0 is not the property of the one-dimensional box for a ground state. And its potential V0 is not equal to 0. That's not the problem, but this is the one. Now the next question, the value of the commutator. This is one important questions. Based on these concepts, you can expect some questions. The value of the commutator x of x comma px is this x into x comma px is the equation 1. When you take this x into px, in order to calculate this, we have to introduce one wave function psi here. For a commutation x into px, it will be like xpx psi minus and px into x psi. When you differentiate this, the value of px we know already. The value of p is minus ih d by dx into psi. Like that, px will come as h and xi will come as h. It's not going to be changed. And differentiate on the psi, x into minus I will become here minus ih x into d psi by dx plus minus to minus plus ih dx into dx will come here. Dx, this is the x and psi are in the uv form, so we have to treat like a uv form. So x will become first and we are differentiating the psi function. X into d psi by dx plus psi into dx by dx. Dx by dx will cancel, so we'll get psi only. So again we are writing minus ih cut x d psi by dx plus ih x into d psi by dx plus ih cut. This is ih cut psi. So these are the same amount but in the different sign. So we are getting cancelled. Both of them are getting cancelled. So its whole value will become ih cut psi. So x into px, the commutation of x comma px will be ih cut. This we are going to substitute here for this value. When you substitute this x comma px value here, x comma xpx, it will become x comma ih. When you are substituting here, x comma px will become ih. So x into x comma px is equal to x into ih. In order to calculate the commutations, we are introducing a psi function here, x into ih psi. On doing the commutations, x into x ih psi, comma ih x into psi. So these are the same but in the opposite signs. When you bring this ih in the front, ih xi minus ih xi, both of them are equal but in the different signs, so getting cancelled. So the whole value of this operation x comma px will become 0. This is a commutation one. So next questions are like this, will be asked based on these concepts, will be asked in the examinations. So based on this concept, it will be better to try many questions based on these concepts. In our test series, we have given so much of questions based on these kind of concepts. Now the next question, As the length of the box increases, this is conceptual questions. As the length of the box increases, the difference between two energy levels become. This is the length of the box. From here to here, length of the box is increasing. The difference in energy levels become negligible. The difference between the energy levels will become negligible, and when the box has energy very large length, when the length of the box increases, the energy will become negligible. At the same time, for a free particle moving in an unbound region, if there is no region of space has quantized translational energy levels, that is, if there are free particles moving in an unbound region of the space has quantized translation energy levels, its translational energy level will become very more. The next question is the delta E of a particle. This is also a very simple one, but a conceptual one, because we can expect on the basis of this concept, if delta E of a particle and the mass of the particle are related, that means when the delta E increases based on the mass of the particles. If the mass of the particle increases, the value of the delta E decreases, because we know that change in energy will become 2n plus 1 h square by 8 ml square. In a particle in a one dimensional box, the difference in energy between the two energy levels, delta E is equal to 2n plus 1, this is the lower energy one, 2n plus 1 h square by 8 ml square. Since the mass is in the denominator, increasing the mass, the energy difference between the two different level will decreases. Now the next question. It's a question. This is one important questions. We can definitely expect questions based on this concept in our TRB. So it is better, I am suggesting all of you to remember these questions and learn this concept. The value of commutation of Lx and Ly. Yes, these are the operators, angular momentum operators. Lx is equal to, we know that its value will become Lx is equal to y h cut by I d by dz minus z h cut by I, this is h cut by I d by dy. We can simplify this form into y pz minus z py. This is the simplified form of this equations. So Lx will become the angular momentum operator y pz by y pz minus z py. Likewise, Ly operator in the y axis, z h cut by I d by dx minus x h cut by I d by dz. This can be rearranged into z. This form will become px. h by I cut d by dx will become, this is dx and dy. dz, it will become z px minus x pz. Likewise, Lz in the z directions, x h cut by I d by dy minus y h cut by I d by dx. This while I'll give you one important things to remember. If it is an x-axis, we have to start from the others. Then the otherwise x, then y will become here. Afterwards, x will become here. This is the in this way only we have to remember in our mind. X, and if it is x, z will, if it is z term will not come here. Only x and y will come here. First, if x has come, then y will come here in the denominator, and this y will come here, and the x will come in the denominator. In this way we have to learn this. This can be rearranged into x py minus y px. In this way we have to remember this. Though commutation of this Lx and Ly operators, angular momentum operators, Lx and Ly operators, we can rearrange as Lx Ly minus Ly into Lx. This, on doing a very big calculations, we can get I h cut by Lz, or if it is an Lx and Ly, we will get the I h cut Lz. Likewise, if it is Ly and Lz, its value will become I h cut Lx. The one operator is not coming here will come here. So Ly and Lx will come here, y is not here, so it will become I h cut Ly. Likewise, so commutation of this angular momentum will get the values of different angular momentum operators. Now, likewise, this Lx operator and y operator, the position operator in the y directions, will get the I h cut z. Likewise, this is the position. Ly into z will get I h cut x. Lz into x will get I h cut y. So in this way, we can expect questions based on this concept. Likewise, Lx into x. If it is Lx into x, we'll get 0. We'll get 0. Ly into y will get 0. So these are the commutations of these operators. These are the concepts, very important. Based on this, we can expect some questions. So in this session, we have seen some important questions from the unit number 9. In this part, in the next part, I will give some more important questions from unit number 9, quantum chemistry plus macromolecules. So thank you so much for watching this session. Thank you.